Right, here's a quick video for anyone who's missed the lessons so far on series circuits and parallel circuits. So as you can see in this little piece of paper, and just quickly go through the learning intention. Sorry if the camera's a bit shaky. I'm holding it with my hand. I'm just doing this quick and I'm just going to do it with one take, but it's meant just to support you. So the learning intention. You should understand the differences between a series circuit and a parallel circuit. And you'll know you understand and have met that learning intention if you can draw a series and a parallel circuit correctly, and you should be able to state the advantages and disadvantages of series circuits. Okay, so first of all, what is a series circuit? Well, a series circuit has the components. The definition is the components which are drawn here. There's a bulb and another bulb and a battery. The components are all arranged in a single loop. Okay, and as you can see, the electricity can only go down that path there, either this direction and back to the battery, or the other direction. The direction of the electric current is not important for you. All you need to know is that in a series circuit, the components are arranged one after the other. Now, if you compare that to a parallel circuit, you have the components, so the three bulbs that you can see here, and they're arranged parallel to each other. Just like you were learning in probably maths, a parallel line are two lines that are adjacent to each other, moving in the same direction, as opposed to perpendicular. If I was to draw a perpendicular line, that would be perpendicular, and that here would be parallel. Okay? So this is a parallel circuit because the components are arranged in parallel with each other. So what I've done here is I have set up, if I zoom out, I have set up a series circuit. Right? Now, let's plug this in so you can see it working. Right? It's in a series circuit because the components are all arranged in a loop. So if I plug that in there, and I plug this in here, you might think there's nothing happening, and you're right, there is nothing happening just now. There must be a loose connection. There we go. That's the bulbs lit up. So the first thing to notice is that the bulbs are lit up, right? They're not very bright, okay? As you can see, they're really not very bright at all. It's known as a series circuit because the electricity, as I've said, comes out and there's one loop. It goes to that first bulb, then it goes to the next bulb, and then it goes to the next bulb, and then it goes back to the battery. One thing you should know about with a series circuit is if I unscrew one bulb, which is the equivalent of breaking the circuit, if I unscrew that bulb there, all the other bulbs have went off. Okay, so that's a disadvantage of a series circuit. As soon as one bulb breaks, or there's a breakage in the circuit, the bulbs go off. Now I've just screwed the bulb back in, and the bulbs are relit once more. Okay, so that's a disadvantage. That happens with any bulb. If I unscrew this bulb, if I zoom out, and hopefully you can pick this up, I will zoom in to show you. That bulb there's no wanting to unscrew it. There we go, it's unscrewed. And as you can see, the bulb has went off, and the bulb has went off. So that's a big disadvantage. Could you imagine having Christmas tree lights with maybe 100 bulbs, and one of the bulbs was to blow? How endless would that be, having to find which bulb was the bulb that had blown? You'd be there for ages, testing every single bulb to find out which bulb was the faulty bulb. There is an advantage though. The advantage of a series circuit is it's dead simple. All you simply do is just take one wire, connect it to the next one, and then connect it to the next one, connect it to the next bulb, and then connect it back to the battery. You don't need very many wires either because, well, it's just a simple circuit. So there's two advantages. It's simple to understand, and it uses few wires. But the disadvantages are that if one component breaks, you've got to work out which component caused the problem. And also, look at the brightness of the bulbs. It might look on your screen like they're not even on, but if I zoom in very closely, you can see that they are actually on. Okay, now let's compare that with the parallel circuit. And remember, the parallel circuit has the components crossing over each other. If I, just so as you know I'm not playing any tricks on you, I'm going to take this battery over to the parallel circuit. And here we have the parallel circuit. And I have the components arranged one over the other. And as you can see with the wires, it looks a bit messy, doesn't it? It's very difficult to neaten this up to let you see it, if I'm being honest, which is a disadvantage. You use more wires than what you had previously. In this example over here, I had, let's count them, 1, 2, 3, 4 wires, whilst in the parallel circuit, I've had to use 1, 2, 3, 4, 5, 6 wires. So more wires means more copper, more wires means more money. So they're more expensive to have a parallel circuit. And it looks a bit more complicated. Now if I connect this up, straight away you should see an advantage of a parallel circuit. They're a lot brighter. The bulbs are very bright, aren't they? And if I was to unscrew any of these bulbs, well, it doesn't matter. If that bulb breaks, you know that's the bulb that's broken. The others stay on. If this bulb breaks, the other bulbs stay on, and you know that that's the bulb that's broken. And just for completion's sake, if I unscrew this bulb, which is not going to happen because I think that actual bulb holder is broken, so I'm going to cheat and just pull that out, which is the equivalent of it breaking. As you can see, the other two bulbs stay on. So there's a massive advantage. If you had Christmas tree lights with 100 bulbs and you notice one was off, the rest would stay on and you'd see the bulb that was broken. You would simply go to the shop, buy another bulb, put it in, and your Christmas tree lights would work again. So the advantages for a parallel circuit are the bulbs appear brighter, especially when you're using a battery, that is. And there is more than one path for the electricity to flow. So that means that if one bulb was to blow, the other bulbs stay on. Okay, and if you consider the diagram, this idea of path is very important. If in a series circuit, if this bulb was to blow, for example, the electricity would not be able to flow because the circuit would be broken. That's why those two stay off. In this example, the electricity can come down here and it's got a choice. It can go here, or it can go here, or it can go here. So if one of these bulbs was to break, that circuit would be broken, but the electricity can still flow down to the second path and back to the battery, or it can flow down to the bottom path and go back to the battery. So, in summary, there is advantages and disadvantages of series and parallel circuits. The advantage of series circuits are, just one more time, that they are simple to understand. They use very few wires. But the disadvantage is the bulbs, when you're using a battery that is, are not very bright. And if one bulb breaks, the other bulbs, or if the circuit's broken anywhere, so say for example you end up getting a broken wire here, none of the bulbs light up. That's the disadvantage. The advantage of parallel circuits are the bulbs were bright, and there's an alternative path for the electricity to flow. So if one bulb breaks, or you get a broken wire here, or here, or here, then it doesn't matter because the electricity can find an alternative path and light up the other bulbs. The disadvantage is, well, it's more complicated. It uses more wires, which means that they are more expensive to organise. So have a wee think. What would you wire your house up like? Would you prefer to wire your house lights in series? Or would you like to wire your house lights in parallel? Which would be the best for wiring up your house?